Let's talk a little now about shockwaves. As previously noted, these tend to occur where a supersonic flow meets an obstacle of some kind. There are two different types to consider, and also a related phenomena called an expansion fan. The first type we'll consider is called a normal shock, so called because it happens at right angles to the flow. And in propulsion systems, we generally come across this in two circumstances. Firstly, if a supersonic stream in a duct slows down and becomes subsonic. And secondly, if a supersonic flow tries to turn through an angle which is too great for it and becomes detached from the object. A good example of this is a flow round a blunt cone. The flow behind a normal shock in these circumstances is always subsonic. The flow parameters change in the following way. The velocity behind the shock wave is less than the velocity in the front of it, and the other parameters, including the pressure, the density and the temperature, generally increase behind the shock. The other type of shock wave which occurs is called an oblique shock. This happens when a surface turns into the flow, causing it to compress. We should note that if we try and turn the flow by too much of an angle, the shock wave will become detached, as we've just described for normal shocks. The flow after an oblique shock may be subsonic or supersonic, but in our case, when we're discussing ramjets, will normally be supersonic. The other variables show a behaviour similar to that of a normal shock wave. Finally, when a supersonic flow encounters a surface turning away from it, it expands, the opposite of a shock wave. This is called an expansion fan and is a gentler phenomena, actually described by the isentropic flow relationships that we discussed in the previous video.